Greetings and welcome to BeIndie.biz. My name is Alan Thorn, and in this tutorial series we're going to be creating an infinite runner game. In this game the player character has to move a character from left to right while running through a science fiction environment. You've got to avoid the oncoming enemies. I've played this game and my top score is 180 seconds, so if you complete this tutorial, let's see if you can beat that score. Now, I've been a game developer for 20 years, I've been teaching people how to make games for 4 years. I absolutely love the practice of making games, and I want to share that discipline with you so that you can be a games developer. If you've never made games before and you're approaching it for the very first time, then this is exactly the place to begin. We're going to be putting together an infinite runner step by step, completely free on this course inside the Unity Engine 2019. Now, in this part of the course, this part of the series, this is part 4. In this part, we're going to be looking at the infinite part of our infinite runner. We're going to make our game repeat infinitely, the player character looping through the environment. It's not as easy as it sounds, it's actually pretty complicated, but don't worry, we're going to see every step of the way how to create that. So without further ado, let's get started. So in this movie, we're going to be creating the infinite part of our infinite runner. In the preceding movies, we created this level that you can see in front of us here. So basically we have this really long corridor section, and then we have the player character or the player model standing here at the center of the scene. Just going to move him under the light so that you can see that. So we have basically the player character and the world. Now, what's going to happen is this player is going to be able to continue running, and effectively he's going to be able to carry on running for as long as the player keeps playing. Now, the problem with infinity is that as a concept we can't really fully comprehend it, but that's a philosophical problem. We don't need to confront that here, but it has implications for our level, because we can't create an infinitely big level on a finite computer that has a finite amount of memory inside a Unity scene that has a finite capacity. So instead we need to fake the infinite part of this game. And the way we're going to do that, at least in this scene here, let me just demonstrate by pressing play on the toolbar. Inside our scene here, you can see the player goes running way off into the distance. Now in the scene tab, we can see that the player continues running even beyond the end of the level. What we're going to do is we're going to wait until the player reaches a point, let's say about here, and then teleport him back to the beginning of the level. He'll continue running, and when he reaches that teleport point again, we'll teleport him back here, and we'll keep repeating that process to create this kind of infinite effect. And so long as the player never notices, then we're going to get away with this, and that's exactly what we want to do. So I'm going to just come out of play mode here and return back to our level. The first thing that we need to put in place is the ability to detect when the player enters this part of the level. We want to have a collider here so that the player can walk into it. In Unity, a collider is simply an object that allows us to mark out an area of the space inside the level, and we can detect when things enter that space. To create a collider, I'm going to make a new empty game object inside the scene. We've seen how to do that already. We simply choose game object, create empty, and I'm going to name this teleporter because effectively that's what this object is. It's going to detect when the player enters the collider and then teleport them back to their starting position. Now, the thing we do need to be careful of, and we'll see later when we get to the coding part of this repeating behavior, we need to be very careful about where in the level we position this object. I'm going to identify the last part of this level here. So I'm going to grab this corridor section. Now, by taking a look at the mesh and the edges in this corridor section, I can see that the dead center point is this dot, this vertex here at the center of that mesh. So I'm going to grab our teleporter object, which is over here. hold down the V key on that object and vertex snap that into place at this position here. Now I'm going to, in fact, well, when I deselect this object, you can't see it in the viewport. The only way we can select this again is by moving to the hierarchy panel and clicking on it. That's a bit tedious and frustrating. I want to avoid doing that. So I'm going to go to the object inspector, and on this tagging section here, I'm going to select the orange icon to display a label for that empty object so that I've always got a visual indication of exactly where that is in the level. I'm going to zoom out just a little bit. Even if I deselect this object now, I can still left click to select it. So I'm going to position my teleporter exactly at that center position for this last section here. Excellent, that works pretty good. And actually I think I'm going to tag this object as well, just to be on the safe side and just to distinguish it from other objects in the scene. So for the tag section, I'm going to click on the drop down here, and we've got different tags that we can use to label different objects in the scene to kind of indicate to Unity what they are. I'm going to click on the add tag because we don't have a tag for teleporter. We have a tag for respawn, which is about the closest thing we've got here, but I'm going to choose add tag, and then in the label section I'm simply going to add a new tag, which is teleporter, and then I can go back to the teleporter object and in the tag drop down assign that the teleporter tag. Perfect. Now the next thing I'm going to do is I'm going to grab the player object. Now what I want to do with the player is I want to make sure I'm very careful, again, just as we were careful about positioning the teleporter point, I'm going to be careful about positioning the player point. So I'm going to position the player to the dead center of this area of the level here. So actually it's very close to that already. It's this center point. Now I'm going to grab the player root object, and it turns out that when you are vertex snapping objects that have children objects like this, which are meshes, it's very difficult to vertex snap those kinds of objects. So I'm going to just temporarily move the player character outside of the hierarchy for the player root, grab the player root empty object, hold down the V key on the keyboard and vertex snap that to this position. I'm going to reparent the cyborg back to the root here. And then to make the cyborg line up with the parent object, I'm going to grab the cyborg object, and for its X, Y, and Z position, I'm simply going to make those values 0 because these values are measured as an offset away from the parent. And in this case, the parent is positioned here. So the player is now located dead center at that position. Both the player and the teleporter are now carefully positioned. Now when we take a look at the teleporter object, right now it's just a carefully positioned empty object, and we can't leave it like that. We need to make it a collider to have a physical volume in the level so that it can detect the very moment when the player character enters that volume. Really easy to do this. Let me show you how we set this up. I could move to the object inspector and choose add component box collider, or alternatively, you need to make sure the teleporter object is selected. I can move to the menu here and choose component physics and then select box collider. I'm going to press F on the keyboard to frame that object inside the viewport here. You can see we've got this collider volume in the level. Half of it appears below the floor. We don't really need that because the player can never go beneath the floor. So I'm going to move the teleporter, the collider, slightly further up in the level to about this area here. Actually, I'm adjusting the size parameter. I want to move to the center parameter and adjust the Y value here for this collider. I'm going to increase the width of this object. The idea is to make this collider pretty big so that the player can't possibly avoid going through it. I want to do the same thing for the Y field so that now really we have this collider completely surrounding this area of the level, and the player will definitely be running through this. Now, as this is set up right now, this object is not marked as a trigger. If you leave it with this check mark removed, then that tells Unity that this is basically an invisible wall and solid objects cannot pass through it. Now, I don't really want that to happen. In this instance, I do want the player to be able to pass through this object. So what I'm going to do is I want to make this a trigger. So I just need to put a check in that box. Perfect. Now the next thing I need to do is to go back to the player character. Now we can only detect collisions between triggers and objects that have two things. One is they have a rigid body component, and two is they have a collider component of some kind to approximate their volume. When I take a look at this player character here and I have a look at this mesh, I can see that our player character doesn't really have any of these things in particular. It doesn't have a collider and it doesn't have a rigid body. We can see that from the object inspector, where it has just a transform component and an animator component. So I'm going to add those two things to our player character. First, I'm going to add a rigid body by choosing add component and then choose rigid body. This allows the object to be manipulated by physics. That simply means that if I move this up in the air and press play on the toolbar, this object is going to fall to the ground under the effects of gravity. Now, I don't really want physics interfering with how this object is working, and so you can easily deactivate the physics part, including gravity. The way to do that is you just move to the rigid body component, and under is kinematic, just put a check in that tick box. That's all you need to do to deactivate the physical part of this rigid body component. The next thing that I want to do is to approximate the physical volume of the player. We've got this object being affected by physics, but right now it has no kind of mass or substance to it. To do that, we need to approximate it using a collider of some kind. I could use a box collider, but I'm actually going to be a little more precise with this character and use a capsule collider. So I'm going to choose add component and then search for capsule collider to attach the capsule collider to this object. Once again, you'll notice it appears right down here by the feet. That's simply because that's where the pivot point of this character is. So what I'm going to do is I'm going to grab this collider component, and here inside the capsule collider component here under the center field, I'm going to use the Y value to raise the center of this slightly further up. I'm going to increase the height of the capsule collider and maybe lower the center just a little bit. So that's looking pretty good. I might widen the capsule collider radius just a little bit to approximate the character, like something like that. That's looking pretty good. And that really is all we need to do. The last thing that I want to do is to move to the player root object. And because this is the player character, I want to tag this as the player object. So under the tag field, I'm going to click on the drop down and make sure that I mark this as player to activate that. Let's just press play on the toolbar to make sure that our level is going to behave just as it did before. It shouldn't really be behaving any differently. We have the player character now running through the scene. He is going to pass through the teleporter, through the collider, and continue running just as he did before. But the advantage that we have now is we have configured the teleporter and the player so that we can detect when the player collides with that teleporter. That is a critically important step. By being able to detect when that happens, we can then send the player back to their starting position to start creating the infinite runner behavior that we need. So now we're ready to start coding our character. That is to script our character to have this repetitious behavior. We're going to be doing that by creating a script file in the C# programming language. If this is your very first approach to games development, this may be the first time you see and use the C# scripting language. Now, this course doesn't go into all the different features and to all the fundamentals of C# programming or programming generally. It really takes a follow-along strategy. But even if you've never covered programming before, as we go through and create a script file, I'm going to be explaining things along the way. Don't try to get down too many programming concepts at this point. My recommendation here, if you've not covered programming before, is to follow along with me step by step and see how this code actually behaves practically in the level. Great. So I'm going to move back to our project panel. And before I create a new script file, you just want to make sure that you have a coding editor installed on your computer. This is a program that allows you to view and edit script files. The Unity engine by default comes with Visual Studio, which is a programming system that is made available by Microsoft. Now, to make sure that you do have that activated, you can move up here to the menu, to the Unity menu, and choose Unity Preferences. If you're using a Windows PC, it's going to be Edit Preferences. I'm going to bring that window up here and make sure you select External Tools. Now, for the external script editor, you want to make sure that Visual Studio is active here. If it is not active for you, then there are two ways in which you can install Visual Studio to your computer. The first is to go to the Unity Hub application, and in the Installs section, click on the ellipsis icon and choose Add Modules. This program will then show you all the modules that are currently not installed for Unity 2019. So I can see that all these different modules are things that I can potentially install if I want to do so, because they are not already installed on my computer. Now, if you don't see Visual Studio in this list, then you can still download it manually from the home page for Visual Studio. You can bring that here inside a web browser window. You can see visualstudio.microsoft. Here you can download the Visual Studio Community Edition either for Mac or for Windows, so that you can get that onto your computer and begin to edit script files. This is the application that is going to open by default whenever we double click on a script asset here inside the Unity project panel. Now, I do have this installed to my computer, so when I create a script file, it's going to open the script inside that application. To create the script file, I'm going to move to the project panel, right click, choose create, and then choose C# script. I'm going to call this script file teleporter, and actually I want to house this in a good folder structure here. I'm not just going to leave this script file floating around the project panel. I'm going to create a folder for it by right clicking inside the project panel, choosing create, choosing folder, and then choosing scripts. And I'm going to drag and drop my teleporter script into the script folder, and I'm going to be editing it from here. So I'm going to double click on the teleporter script here to open that inside Visual Studio. And what you end up with when you do that is you end up with this script file here. Now, the way this is going to work is we want to detect when the player enters the trigger. So I'm going to delete the interior section of this teleporter class, so that effectively what we have is an open and closing brace like that with empty space between. I want to know when the player character enters the trigger. So I'm going to type void on trigger enter, and in fact, in this helpful way, Visual Studio is going to complete the statement for me. I want to know when we enter the trigger, so this is on trigger enter. You just press the return key on the keyboard to complete that statement, and it fills in the rest for you. Great, so this allows us to detect what is going to enter the trigger. Now, the item that enters the trigger is this other part here. It could be that if we were to have NPCs in the level, it could be that the NPCs enter the trigger, and I don't really want to check if the NPC is in the trigger. I'm only interested if the player enters the trigger. So in this instance here, I'm going to then move down here to this section, and I'm simply going to check if it is the player character. So I'm going to choose if other dot compare tag, because we gave the player character the player tag. So if other compare tag, actually you need to be careful there. Let me just minimize our script file, because this object is going to be entering the collider, but it is the player root object that is tagged as player and not the object that has the capsule collider and the Rigidbody component, which is this cyborg mesh here, which is in fact a child of the player object that has that player tag. So actually, when I go back to my script file, it is the parent object that I want to compare this to. So I can compare the parent in this way here. If the parent has the tag of player, and actually I want to put an exclamation mark in front of it to say, if this object, the object that's entered the collider, is not the player, then really don't even bother processing the next line, just exit at that point, because whatever it is that has entered the collider, it is not the player, and so we don't need to worry about what this object is. But if it is the player character, then we do want to check some stuff. We want to teleport the player back to their original position. So to do that, we need to know, at least initially, what the player's original position is, and that is defined at the beginning of the level. It's defined as the location that the player begins at. So what I'm going to do is I'm going to create a section at the top here that is going to allow us to effectively detect which object is the player object and then to record what its starting position is when the level begins. So I'm going to have a start function here. Actually, I'm going to call this function awake, because when the level begins, this object wakes up effectively. So inside this function, I'm going to find the player object by choosing GameObject dot find object with tag, and I want to find the player object in the scene and get the transform component on it so that I can check what its position is, or at least the starting position of the player character. Now I'm going to keep a reference to the player's starting position. This is a vector object, that's X, Y, and Z. I need to keep track of the player's position in terms of X, Y, and Z. So I'm going to call this player start pos, and by default it's going to equal the initial value of vector3 dot 0, because we don't know what the position is at this line, but by this line we can figure out what the player's position is by choosing player dot position. We can read what the player's position is, and then we can record the player's starting position. Perfect. So let's just test this code so that when the player enters the trigger, we reset the player's position back to its starting position. That's great. So I'm going to choose player.position equals player start position, like that, and save this code. Pretty short script file, but let's see this work. So I'm going to go back to Unity here. I'm going to just press play on the toolbar. Actually, before I'm going to stop, because I've forgotten something. If I go back to the teleporter object, this is the object that we need to use to detect when the player enters this trigger. It doesn't have the script file attached. In Unity, if your script file is going to work, it needs to be attached to objects in the scene. It's not going to work just sitting down here. So I'm going to drag and drop the teleporter script onto the teleporter object, and you'll notice that it gets attached to this object like any other component here. So now I'm going to press play, and now this script file is going to take effect. I'm going to go back to the scene tab. Notice that as the player enters this, he's going to get teleported back to his starting position. And there we have it. Looking pretty good. This player is now continually getting teleported back to the starting location over and over again. Now, that's a great start, but there is a small problem. And the problem relates to the exact positioning of the teleporter object and the player object. The reason that the teleporter has been positioned to the exact center of one of these corridor sections, and the same with the player character, is that we want to make the jump, the teleportation, imperceptible to the player. If, for example, the player teleported at this location here when he was pretty close to the edge, and then teleported back to a center section of this, the player would be able to notice the player's relative change in position by the wall sections here. Because we're teleporting from the middle to the middle from one section to the middle of another section, then they're actually maintaining their relative distance to and from the walls to make this change imperceptible. But there is a catch, and the catch is this. At this point here, when the player enters the trigger, depending on the speed of their computer, the number of frames per second, and all kinds of other system-specific stuff, it's possible that when the player enters this trigger, in some cases, on some computers, he might enter it here, and then the on-trigger event happens and we get notified about it at that point. But if the player did some sort of mammoth leap and reached to the center of this trigger, we would get notified about it here. We can't be certain where inside this collider the collision detection could happen. It could happen at any point within this volume. So how can we counter for that here when the player gets teleported back? I mean, for example, if the player gets right to the end of this collider here and then gets teleported back to the center, there is a slight change. The player would have been here when he got teleported, and he's been teleported slightly further back to this location. We want the player to maintain the same relative distance from the teleportation point. Well, we can do that really easily. The way we're going to do that is go back to our code here, and we want to find out what the relative difference between the teleportation point and the player is. We can figure that out easily by choosing vector3. We'll say position difference equals the position of the teleportation point minus the position of the player. This will give us the difference between the two positions, the amount of offset, so that when we set the player back to their original position, we simply want to add that position difference onto it. And it really is that simple. I'm going to save the code and go back to Unity here, let that code compile, and then press play on the toolbar to test out our code. To press play, this time the player is going to hit that teleporter, go back. Now, to give this at least an initial test, and it may not be exactly right at the moment, we need to tweak it perhaps a bit further, but to give this an initial test to see if we're on the right lines, I'm going to grab the scene camera, which is following the player character here, and I'm going to position this at a location where we can at least get an early visual preview about what's going on here. So I'm going to rotate the camera just a little bit and move it up in the scene, move it slightly further back from the player, move it slightly further over, and something kind of like that, so that we can kind of get a look at the player. Now I'm going to make this camera a child of the player object, so that as the player object moves, the camera will follow. And so the player is running along. Boom, the player's gone back to this point. Now, we notice the difference in the jump there simply because the player is reaching pretty close to the end of that corridor section, and there's nothing at the end, so we can see the change when it occurs. But what happens if we grab all of these corridor sections inside the level, and now we're going to start putting together some empty space. So I'm going to duplicate these sections here and move them slightly further forwards and do a vertex snap there. I might even do maybe another section again with a duplicate and move that forwards so that it's pretty far into the distance here, and snap those into place. Down here-ish. Actually, that's not the right location. Snap it down to there. So we've got a fair distance here to travel. Now Unity is going to go ahead and bake the lighting for these extra sections that we've just added. The only reason we've added these is to help make the effect more imperceptible. You can still see inside the camera view here that we can still see a little bit of the difference. We're going to be able to fix that later using fogging effects, but we can even try to minimize it here by grabbing, for example, the camera and changing the orientation just a little bit more to push that out of view. Yes, it really is a cheat, but it works. So what I'm going to do is I'm going to wait for this to finish baking so that the lighting for these further sections along in the level here is going to change, and I'll resume the recording after this is finished baking. So now the lighting has finally finished baking. Let's see how it looks inside the scene here. So I'm going to press play on the toolbar, and let's take a look at how the repetition looks. So the player character's moving along, running along to the end. You can see that here, and there was the jump. You can see the jumps here somewhere. Let me just select the teleporter. So the teleporter's there, and the player then jumps back. Now this is looking better. There is still some noticeable artifacting here. At the point of the teleportation, we can see that there is still something of a jump. Now part of that is to do with the scene lighting. You can see that as the player moves through various areas, the lighting is giving us an indication of where he is, so that when he's teleported back from one area to another, we can certainly see some change in the lighting effects here. We could try to mitigate this effect a little bit further by doing some stuff like, for example, just moving the teleportation point maybe if we wanted to, and to tweak the positioning of the teleportation point so that actually the effect looked better. Let's just see how that looks, for example. Boom. And again, you can see that we still do notice a difference, perhaps not so much. We can still see the changes in the lighting effects. I'm going to move that forward just a bit more. Again, we can see it seems there even less we notice a difference. So you can see here that is looking much smoother. That doesn't solve all of our problems. We still have quite a bit of work to do. We still need to refine the player's lighting, because in some areas where he's not being affected by the lighting, he is completely black. And then when he moves into areas of lighting, then suddenly he becomes illuminated. And again, this is a problem with the scene lighting. I'm going to stop playback here. So we can see that we do have some problems with the scene lighting that is changing how the player character is shaded right here inside the viewport. So we need to fix that. That is going to help us fix this infinitely repeating effect here. But we are well underway now to creating infinite looping behavior for our infinite runner game. So I hope you found this part helpful. This has been BeIndie.biz and I've been Alan Thorn. In the next part of this tutorial, we're going to look at how we can set up a camera system and get this blending for this infinite running working much better than it is now. We have a good beginning, but we can still do better. So stay tuned.